Okay, Assalamualaikum and good morning. Today we will be present our topic for Project Numerical. First of all, we are from group number 2 and our topic is system of linear equation. Okay, for this topic, what the method that we use is Gauss elimination method and Gauss elimination method with pivoting. Okay, next is this is our group members. It consists four of us. First is Mama Asnan bin Mama Ali. Second is me, Mama Hafiz. And thirdly is Muhammad Reza Irfan bin Muhammad Rezauddin. And lastly is Ahmad Aminuddin bin Zainuddin. Okay, for this question, we get from past year paper. Okay, for this question, okay, let me read it first. The question. Okay, the question is: a biologist has placed three strain of bacteria denoted 1, 2, and 3 in a test tube where they will feed with three different food sources A, B, and C. Okay, each day 7 units of A, 400 units of B, and 500 units of C are placed in the test tube. Each bacteria consume a certain number of units of each food per day as shown in the table below. Okay, this is the table of the info that we need to using Gauss theorem, Gauss elimination method to solve to get the answer. Okay, okay, this is method that we use. It has calculation and simulation. Okay, this is Gauss elimination method calculation. Okay, we just get this data from the table and then using step by step to solve to get the answer. Okay, for Gauss elimination method, we need to make this row triangle the bottom uh value 5, 1 and 3, make it to 0 like this final answer. And after we get the final answer, we just put in calculator and we will get the final answer. This just use metric function in calculator. Okay, okay, next. This is for simulation. Reza will explain for simulation part.
Okay, so for the next is a simulation from the manual calculation for cost elimination method. So this source code is show this the line first and second is the data we need to insert from the table 212, 510 and 131, and then B is equal it's mean the unit from the question 700, 400 and 500. And then n and x is n is about the length of the augment matrix that we need to insert in the source code. Okay, next is for j, this line for j equal to 1 and n minus 1 is for the how we need to what we said what we need to rearrange the number in matrix shape 3 by 3. Okay, and then uh, uh, below that n is the final result after we after the calculation when the row 3 and row 2 become 0 for to get the final answer. Okay, next. So this is the result from the command window. Okay, first we put A to get the matrices shape from the data. Okay, so we can see A, and then B for the 700, 400 and 500 for the uh we can say that the answer from the A, and then uh we type augment to get a 0. Okay, to get the 0 for the row 3 and row 2. and then there will be the difference for the value for the row 1, row 2, and row 3. And then after that, after we type the as well, after we command as, and then we give they give the final answer. That's same as manual calculation. Okay, thank you for me.
Okay, for the Gauss elimination method without pivoting, there is not much different from the without pivoting. As you can see, the different with pivoting and without is first we look at the first column like 2, 5, 1. The first column, the first column at the matrix 2, 5, 1. If the number, the lowest number, let's say the 2 is at the bottom of the column and 1 is at the top of the column. First, we must swipe all the row from row 1 and row 3. We must swipe, but because our linear equation is okay, doesn't have number one, the first, the, yeah, as we can see, at the third column is number one, so it's already at the lowest row. So as we can see, we do step by step, same as we are pivoting, and then we see at the after eliminating x1 from R3, we can see we must swipe R3 and R2 because the second column, which is negative 1.5, at the row negative 1.5 and row 2.5. Negative 1.5 is much lower than 2.5. So we must swap the R3 and R2. And then we do same as eliminating X2 from R3. And then we get the result. After that, we just use calculation and then we get the final answer.
Hello, my name is Ahmad Mahyudin bin Zainuddin, and I will explaining the simulation for Gauss elimination method with pivoting. So as you can see from the coding, I define my data from with A and B. A represents the data that is being given from the bacteria strain, and the B is the data that comes from the units that are placed in the test tube. So what I do, I define the X as the augment matrix for A and B. Also, I execute my coding. As you can see, I put a command here, pivoting section starts, as to check the pivot element is 0. And if the element is required, the row below for a non-zero pivot element. So after that, I make a print text as pivot equation has percentage d pivot, so exchange row percentage d to define the value of j, xj, and k. And then after that, I switch the row that has 0 pivot element and with the row that has a non-zero pivot element. And then I end the coding there. Also, I continue with the length of the length of the matrix. And I execute the print as divide the pivot row with pivot element to normalizing the pivot row. And also I print the multiplying RAO to define the new matrix and subtract from the previous row. Next. So this is the result. I started by executing the data. The 212510132 is A, and the 700 is B. And then I swap the row from R1 and R2, and then I eliminate from R2, and then I divide uh, divide the pivot row, one with pivot element, two to normalizing the pivot row, and next select. And lastly, I multiply the, as you can see, I define the RO3 with negative 0.667 and subtract from row 1. And finally, I multiply with 3.333 and subtract from row 2, which equals, has been given 68, 60, and 252.
Okay. For the conclusion for our project, what we find is whether you can use any of method in system linear, such as Doolittle or such as Doolittle. I forgot another one. You still can get the final answer same with Gauss elimination method or pivoting. Okay, I think that's all from our group. Thank you. Settle.